In the first lecture on the third module, we discussed about materials that are required for marine environment, what are the special characteristics which are required to comply the material to be used in marine environment. We also discussed about the variety of specific properties which are demanded by various international codes, and we also saw a classical example of steel as a material for marine environment. In the present lecture, we will talk about other kind of materials like aluminum, titanium and composites and their suitability for marine environment and material for construction of marine structures. We will also have a very brief lookout at non-ferrous metals which can be used as construction material. Ladies and gentlemen, to be on the top in the list today's lecture, we will talk about aluminum, which is a very phenomenally attractive material for marine environment. There are specific reasons why aluminum is preferred as one of the construction material for ocean structures. Aluminum is used in the construction of hulls, deck houses and hatch covers of commercial ships. It is also used in equipment items like ladders, railings, gratings, windows and doors in the building blocks in the topside facilities of offshore platforms. The passenger vessels utilize large quantities of aluminum in superstructure and equipment as well. Small and high speed boats in particular are constructed of aluminum using 5XXX alloy, a specific pattern of an alloy of aluminum. Now, aluminum alloys have salient advantages over other material. Aluminum alloys have strength comparable to that of mild steel. This enables to design the offshore members with equivalent strength as that of steel, but with a weight saving up to as high as 60%. Weight saving is achieved actually because aluminum has a specific weight which is 1/2.5 of that of steel. Because of this phenomenal advantage of aluminum, aluminum can exert the same strength as that of the mild steel, at the same time the weight is highly low as compared to that of steel. The cost of aluminum approximately is about 2 to 3 times as that of steel used for offshore construction. However, in case of steel and aluminum maintenance cost put together, if you add steel and the maintenance cost of steel, it is about 1.5 times of that of aluminum, because steel has got a phenomenal expenditure towards its constant maintenance. If you look at the statistics over a 10-year period of time, initial investment of aluminum as a member, structural member, may be marginally high, but if you look at the total cost of maintenance as well as initial investment, steel will cost you about 50% more than that of aluminum over a span of service life of about 10 years. However, aluminum cannot be used as a construction material for offshore structures for all kinds of members. There are limitations, we will discuss them in the successive slides. Aluminum has few more salient advantages. Aluminum extraordinarily advantageous because it does not need any protective coating as that of steel. The cost over life of the structure is lower because it is as good as free maintenance. Alloys of 5XXX series of aluminum are essentially used very widely in marine applications. Yield strength of this material varies in the range of 100 to 200 megapascal. So, aluminum is seen as one of the very alternative and advantageous material with respect to steel, and aluminum has lower specific weight compared to that of steel. Therefore, the overall weight of the construction material and used in offshore structure will be phenomenally low, which is claimed as one of the important advantage. Another advantage in the construction point of view is that aluminum is more or less free maintenance material, whereas steel need to be maintained constantly because steel gets corroded in marine environment. Commonly used are in pressure vessels, basically where LNG transport ships are being deployed in offshore. Insulations are also provided with aluminum, so that low temperature do not reach the ship's hull. The next competitive material in the line, which again competes with aluminum and that of steel as a construction material for offshore and marine application, is titanium. Titanium alloys are increasingly commonly being used now in offshore application. Titanium, ladies and gentlemen, is as strong as steel, but yet about 50% lighter. High strength, low density and corrosion resistance of titanium alloys contribute positively towards the cost reduction and becomes attractive for this material to be recommended for marine applications. Weight saving is one of the important and great advantage if you talk about design of offshore platforms, because and aluminum is commonly used in small semi submersible platforms. High strength to weight ratio, that is high strength at lower weight, is a most attractive feature of titanium. Good corrosion resistance and relatively high modulus of elasticity are considered to be additional benefits of titanium alloys. Used for surfaces which cannot be painted, such as propellers, special valves and piping, ladies and gentlemen, possibly titanium is the only material which can be suiting all these requirements, as you see in the slide here. It has got a very serious disadvantage. Initial cost of investment of this material as a construction material for offshore platforms is phenomenally high. Titanium actually requires no corrosion allowance at all. Hence, equipments can be designed to satisfy the minimum requirements for mechanical strength and handling as well. Titanium has an outstanding corrosion resistance even in heavily polluted sea waters. Titanium alloys can be classified into three groups, as you see now: alpha, alpha beta and beta. This grouping of titanium alloys actually depends on the microstructure of this material. Pure titanium has lower strength and high value of ductility. This is considered as a disadvantage. Therefore, this microstructure has been altered by adding small amount of elements to their chemical composition, which increase the strength as well as decreases its ductility marginally. Why titanium is used in offshore application? It is a very interesting question. There are specific reasons for this. Increase in disruptive failures of stainless steel and copper based alloys posed a very serious question to offshore application in the safety point of view. So, in safety concern, titanium is upcoming replaced material in comparison to stainless steel and copper alloys, in particular for offshore applications. Titanium continues to be available at a competitive price. This is one of the important advantage what titanium claims in the recent past. When titanium was launched as a construction alternative material for marine application, the introductory cost of this material was phenomenally high. So, people were not comfortable to invest on a high range of material for a marine application whose service life is highly limited. So, the initial investment of offshore applications go high when titanium was thought to be replaced by construction material like steel and copper alloys. But in the recent past, titanium is available at a very competitive and most importantly a stable price in the market. So, there is no fluctuation of material cost as far as titanium is concerned in the market. The great advantage what titanium now claims is growth of fabrication experience. People have been trained, skilled laborers are available, techniques have been imparted impartially in different methodologies, where fabrication of titanium alloys can be comfortably done with recent advanced technologies for pipings, fittings and systems. So, ladies and gentlemen, availability of titanium at a stable price, a relatively a competitive price. I will not say it is cheaper. I am agreeing that titanium is an expensive material compared to steel, but it is competitive because it is having other parallel advantages. It is phenomenally high corrosion resistant. So, the maintenance cost practically becomes 0 when you use titanium or for example aluminum. Of course, the strength of titanium can be as high as 400 megapascal, which is equivalent to steel. So, you have a material here which replaces steel at an initial investment of higher cost marginally, but at a stable price, and phenomenal methods of fabrication techniques are available. Therefore, for piping, fittings and systems, people are now preferring titanium as a very important alternate material in offshore applications. Improved availability of information to the design engineers of useful combination of properties of titanium are now available in the recent literature. In flowing or a static sea condition at temperatures up to 130 degrees centigrade, titanium surfaces are immune to corrosion. It is a very important and attractive property what titanium, basically titanium is the only material which possesses this characteristic as on now. At a very high temperature of 130 degrees Celsius in a marine environment, titanium remains as corrosion free. On the other hand, if you look at steel under this case and other metals and alloys corrode terribly at this environment. Titanium is immune to what we call crevice corrosion up to at least 70 degrees Celsius in seawater. If you look at a comparative study of this specific crevice corrosion characteristic with that of steel, stainless steel possesses this characteristic only up to temperature of about 10 to 12 degrees Celsius. So, titanium has a categorical edge of advantage over stainless steel as a material in terms of crevice corrosion resistance, and it possesses advantage over other metals and alloys because it remains immune to corrosion even at a very high temperature of 130 degrees Celsius. Ladies and gentlemen, here is a table which compares titanium with other kinds of material. It is not deliberately shown to you so that titanium is the only material which is promoted and projected for offshore application, but people do not use titanium because of fear and because of high increase in cost, but it is not true in the recent past. Look at the table which gives you a comparative advantage of titanium alloy with respect to stainless steel, which is duplex 6 mono, and stainless steel 316 and copper based alloys. If you look at the modes of corrosion, general corrosion, you will see all of them are almost resistant except the copper based alloy which can be susceptible. If you look at the corrosion, crevice corrosion, copper based alloys and stainless steel 316 are highly susceptible. Stainless steel duplex also susceptible if you increase the temperature beyond 25 degree, whereas titanium alloys remain resistant up to a temperature of about 80 degrees Celsius. If you look at the pitting attack, which is a very common disturbing phenomena of members in marine application, copper based alloys and stainless steel 316 remain susceptible, whereas titanium alloys are highly immune to this. If you look at the stress concentration, all of them are almost susceptible except the titanium alloy which remains as resistant to stress corrosion. So, ladies and gentlemen, look at the modes of corrosion and you will find titanium alloys almost fulfill all of them except very few, whereas other kinds of material do not qualify in majority of the cases. So, titanium has a very clear edge as a construction material for marine application. The only demerit which is seen now is the increased initial investment in terms of its cost. Naturally, I strongly agree titanium and aluminum are more expensive than steel if you look at the initial cost alone. If you look at the maintenance part together for a period of service life of 10 years, you will find, ladies and gentlemen, titanium and aluminum can be a competitive, affordable, replaceable material compared to that of steel in marine structures. The first all titanium fishing boat was launched in Japan in the year 1998. Weighing only just 4.6 tons, the boat was about 12.5 meter long, which could travel at a phenomenal speed of 30 knots. Of course, there has been some mechanism by which the fuel efficiency was improved in this boat to attain this speed. Operational cost savings include no necessity for hull painting and easy removal of biofouling. Ladies and gentlemen, focus on one important environmental impact of material being used and recommended for offshore application. You will see biofouling is a more attractive area where people started paying more attention to material degradation processes and their counter effects on the bioorganisms in the seawater. So, titanium still remains advantageous because it has got lot of phenomenal characteristics which does not affect or which do not degrade to cause a biofouling in seawater. Progressive degradation of glass fiber boat hulls by repeated fouling and cleaning is an ongoing penalty for Japanese inshore fishing fleet. Therefore, titanium has been now phenomenally used increasingly as an alternate material for small vessel constructions and shipboat building in countries like Japan. Titanium also has common which is increased in the recent past in applications in marine environment. The reasons are the following: because of its very high strength, high toughness and exceptional and phenomenal erosion and corrosion resistant, titanium is currently being used in majority of offshore applications. They are being used as submarine ball valves, fire pumps, heat exchangers, hull material for deep sea submersibles, water jet propulsion systems, propeller shafts and propellers, exhaust stack liners, naval armors, underwater manipulators, high strength fasteners, yacht fittings, shipboard of cooling and piping systems, many other components in ship design. Now, you will see titanium has got very increased application in marine environment in the recent past. The other competitive material which race with aluminum and titanium in today's lecture are composites. Now, what are composites? How do they have advantages? How advantages are being claimed by composites with respect to that of aluminum and titanium and against steel? Let us see them now down the line. Composites are materials which consists of two or more constituents. The constituents are combined in such a manner that they keep the individual physical phases and are not soluble in each other, not to form a new chemical compound. One constituent is what we call reinforcing phase, the other one is a matrix phase. The one in which the reinforcing phase is embedded is what we call matrix. Brick made of clay reinforced with straw is a classical example of a composite. Let us quickly see how composites are classified. Composites are essentially classified based on the geometry of the reinforcing phase. Particulate reinforced composites, which we call them as PRC, flake reinforced composite FRC, fiber reinforced composite again FRC, continuous fiber, short fiber and viscous can be again a sub classification in fiber reinforced composites. It is also classified based on the type of matrix what to use. Polymer matrix composite, can be metal matrix composite, can be ceramic matrix composite, can be carbon fiber or carbonaceous matrix composite, can be fiber reinforced polymeric composite, it can be particulate reinforced metal matrix composites. It can be an hybrid variety which uses multiple reinforcements and matrices. For example, carbon fiber and glass fiber and epoxy matrix is an hybrid variety of example of a composite. Now, glass reinforced epoxy, for example GRE, which is seen in the literature, has found a phenomenal application in the piping systems in offshore environment. They offer good resistance against highly corrosive fluids, because as we understand the operational temperature and pressure in case of exploration of oil in the subsea are entirely in a very high range. So, I need a pipeline, I need a stack or I need a riser which can be immune to this kind of highly corrosive fluids at very high temperature, at various pressures, adverse soil and weather effects, etc. So, GRE, which is a glass reinforced epoxy composite, has been found a increasing application in the piping systems, which is majority used in offshore environment, because they have got very good fire resistant, chemical resistant, etc. Pultruded glass or phenolic gratings are generally particular type of composites which have been commonly used in offshore piping systems. Worldwide, many industries are now manufacturing pultruded or compression molded composite grades or gratings, which have got very wide variety of applications in industry. Ladies and gentlemen, in day to day life you must have been seeing this in wide applications. For example, industrial walkways, skywalks, handrails, ladders, cable trays, etc., and chemical and pharmaceutical companies which has got highly corrosive environment have started using GRE composites for their applications. The performance of composite product mainly depends on how do you fabricate it. The pultruded FRP grating is an assembly of a pre-shaped FRP pultruded sections joined together by various mechanical means. So, remember, ladies and gentlemen, the characteristic of a composite can be advantageously modified depending upon the process of fabrication. So, one such interesting fabrication methodology which is commonly used in for material as offshore application is pultruded FRP grating. Pultruded structural profiles provide extremely useful options to offshore designers for materials and members in offshore construction. Pultruded products, due to high fiber to resin ratio, this ratio in the literature is as high as 70 to 30, helps in achieving a higher load bearing capacity. So, the properties and the characteristics and the methodology of fabrication are suitably modified engineering design that the load carrying capacity of a pultruded product of a composite can be equivalently good as that of any other material which is being used for member construction of offshore industry. Pultruded gratings have longer span with less deflection. So, that is another advantage when you are going to use them for decks in the top side. If you compare this with the molded grating of that of composites itself, pultruded grating still have an edge over the molded grating because they can sustain longer spans with lesser deflection, which is one of the important design criteria for the top side in offshore structures. The pultruded grating panels can be easily cut, therefore, fabrications become simple, can be modified as per your dimension requirements, therefore, fabrication, construction easiness, dismantling and transportation becomes as simple as, so people get attracted towards using pultruded grating composites for topside construction in offshore industry. In recent times, phenolic gratings are also being extensively used in offshore application where fire safety has become very important. As we understand, ladies and gentlemen, you must have heard and learnt many accidents take place commonly in offshore industry topsides, but not in the recent past. People have been doing intelligent designs in the recent past, so catastrophic accidents because of fire are greatly avoided. However, there has been instances naturally in offshore industry where fire accidents took place. So, now in the recent past people have started replacing some of the material as phenolic grating material which has got a very high resistance for fire protection. The main advantage of a phenolic grating lies not only in the performance during fire, but most importantly the ability to retain the significant level of functionality even exposed to fire, including low smoke and low emission. Ladies and gentlemen, you must understand, in case of many fire release models, emission control models, it is fire which is less hazardous, but the smoke is more hazardous than fire. People actually become panic only because of the dark thick smoke and smog, not because of fire. So, you see phenolic gratings have an advantage of having good fire resistant. When they are exposed to fire for a larger period, they got a very low smoke and emission. That is very important advantage as phenolic gratings are concerned. Let us quickly look at the classification of composites. Based on the geometry of reinforcing phase, I can say particulate reinforced composites, flake reinforced composites, fiber reinforced composite which is having continuous fiber, short fiber and viscous. Based on the type of matrices, we can have polymer matrix composite, metals matrix composite, ceramic matrix composite and carbon fiber matrix composite and fiber reinforced polymeric composite and particulate reinforced metal matrix composites. You can also have a hybrid variety as I discussed in the previous slide. Composites actually meet diverse design requirements. They also exhibit high strength to weight ratio, that is, at a lower weight material gives you higher strength. So, they meet high strength to weight ratio compared to that of other conventional materials, which makes it attractive for offshore application. Composites in the recent past proved to be worthy alternative to other traditional materials even in high pressure and aggressive environmental situations. Composites have special merits, ladies and gentlemen: superior corrosion resistance, exhibition of excellent fatigue performance, good resistance to temperature extremes and wear, especially industrial sectors. The tailorability, that is the constructability of composites to suit specific applications, has been one of the major advantage of composites, such as imparting low thermal conductivity, low coefficient of thermal expansion. So, the properties, the structural properties, the mechanical characteristics of composites can be easily altered by method of manufacturing, method of fabrication, so that you can make it as low thermal conductive and having low coefficient of thermal expansion as well. So, this kind of tailorability makes composite as an advantage material for offshore materials. In addition, they have a very high axial strength and stiffness as well. Extensive applications are seen in oil and gas industry in the recent past. In 15 years, significant advantages and advances have been made in the areas of composite pipework and fluid handling. High cost to replace steel piping in retrofitting them prompted people to use composites. Increased longevity in new construction is an added advantage which is gained by use of composites in construction material for marine applications. Composites, ladies and gentlemen, have now replaced heavy metal pipelines with lighter ones, because there is a phenomenal decrease in cost. Composite pipes are also used for fire water piping, seawater cooling, drainage systems and sewage applications. Composites also have many advantages and applications. The cost advantage of composite products are much greater when they are replaced by expensive corrosion resistant metals such as copper nickel alloy, titanium, etc. Their resistance to corrosion helps in improving reliability and safety and also lead to lower life cycle cost. This is a very important factor which is an important assessment in construction management technique of offshore industry. With technology innovations and developments in processing and products, composites become an attractive candidate for many applications. I will list few here: topside application in offshore platforms, downhole tubing in the subsea. We have discussed this in module 1 in one of the lectures, and many other similar applications where composites have become very attractive in the recent past in offshore industry. The selection of suitable resin plays a very important role for imparting the durability characteristics to composite when exposed to aqueous fluids. The important issues relating to material selection for composites are smoke and toxicity in fire, mechanical properties including resistance to impact and adverse environments. So, composites are recommended very fairly for piping system. As we saw in the previous slide, GRE is one of the important composite, which is glass reinforced epoxy resin. It is a piping system which are suitable for offshore environment against highly corrosive fluid at various pressures, temperature, soil and weather conditions. GRE is popularly being used now for oil exploration, desalination, chemical plants, fire mains and dredging. Here is a photograph of a GRE piping system used in one of the topside process plant in offshore industry. GRE pipes are very common in oil transportation as well, where resistance to crude oil, paraffin buildup as well as ability to withstand relatively high pressure are required as important characteristic in case of transportation. GRE piping system is also being used on offshore rigs for seawater cooling lines, air vent systems, drilling fluids, firefighting systems, ballast systems, drinking water lines in many other applications in offshore segment. GRE pipes are lightweight pipes and therefore they reduce the weight and the construction cost as far as piping system is concerned in offshore industry. The established oil fields use GRE pipes for high pressure and steam injection lines for recovery systems. GRE piping system can withstand detrimental effects of brackish water when expelled under pressure from fire mains. Effect of rupture free GRE pipes under such shocks make the system more reliable. Therefore, people get attracted of using GRE piping system for fire retardation or fire fighting systems as well as recovery systems in oil preservations. Chemical resistance, service temperature of such composites in particular fluid basically depends on the resin formulations, additives being used in manufacturing methods, etc. So, we are not discussing about the chemical manufacturing process and methodologies of manufacturing GRE pipelines or composites as a material, but this lecture focuses on how composites can be seen as a very effective alternative of construction material in offshore industry. Composites also have very wide variety of application in the top side. Composites, grids, gratings, handrails, cable trays, ladders, decks and flooring in offshore industry has become recently increasing, which have been used for fixed and floating offshore platforms world over. In topside application, the inherent corrosion resistance of composite material reduces, ladies and gentlemen, the life cycling cost by minimizing its maintenance actually. The low cost, minimum topside weight and ease of transport can be seen as list of advantages of using composites as topside material in marine applications. Here is a photograph which shows you the use of handrailing, grating in the pipeline where we have used composite material as an alternative to steel. There are other non-ferrous materials which can be also used in offshore construction. For example, cupronickel alloy, which is mixture of copper and nickel in the percentage of 69 and 30, is an alternative material for construction offshore industry. The other one which is very popular and being used is K-Monal alloy, which is combination of nickel and copper at 65-30, and other material like aluminum and titanium are also being included in fabricating and manufacturing this K-Monal alloy. The next competitor down the line in the race is nickel copper 400, which contributes 66% from nickel and 31.5% from copper and other material which excludes aluminum and titanium. Bronze is also finding an increased application in offshore constructions, Cu 90 and zinc 10% been used in this. Cupronickel is a very common and popularly used alloy which is widely used in condenser applications such as tubes, tube sheets and pipelines, manifolds with one inlet and many outlets or one outlet and many inlets. So, you have got different kinds of material which has been competitively being recommended for offshore application. Ladies and gentlemen, we are slowly getting into detail of different kinds of material which are recommended for offshore application. Remember carefully the material mechanical properties, structural characteristics, their selection, their classification, their applicability, their treatment, their fabrication ease, their transportation, all factors do matter an engineer to find out whether which material should be properly used. If you see, I can also recommend material based on international recommendations given by the codes. Various codes recommend material for different applications. However, the variety of these applications makes an engineer to select a suitable material for the required service life of offshore application. In the next lecture, we will talk about more on different other kinds of material. As you see from the lecture here, there are alternative non-ferrous materials like cupronickel, K-Monal, nickel, bronze, which are widely used for different appurtenances like valves, pumps, heat exchangers, where no other material can substitute the strength and the functional requirements. In the next lecture, we will discuss about more non-metallic materials like fiberglass, tempered glass, wood, concrete, ferrocement, etc. Thank you.